Good morning. I am Saujanya.
I am Sujal.
And I'm Mihira.
We are here doing our MPNC project, RFID based attendance system in assembly language using 8051. And we are going to show you a demo, and also the code will be given in the
Okay, so this is our hardware prototype of the project, which is the RFID attendance system. So here is the RFID reader module. This is for the power supply to the microcontroller system. This is our 16:2 LCD display, a switch to power, and this is the potentiometer to set the contrast of the LCD. So now I'm going to show you the internal connection of this board. Okay, okay. So this is the internal connections of our hardware prototype. So basically, this is the switch and this is the battery. We have used here the battery 9-volt battery because each and every time you can't power this attendance system with the cable. So to make it wireless, we have used the battery here, which is a 9-volt battery. Now coming to the LCD display, eight of the display data pins have been connected to the port 0 of microcontroller. This is 8051 microcontroller. Specifically to say, it is 8069 S52 chip. Okay, now this is the RFID module. And these two, this pin is a data pin which transmits the data, which is 12-digit code, to this microcontroller. This microcontroller will compare the values, the 12 values, and will print the statement according to it on this LCD display. And normally we have given the connections of LCD power up, backlight, LCD contrast and all, and VW pins. That's it.
Now I'm going to explain the coding part for our project, that is RFID based attendance system. Now this is our entry point. That means from here on the code will start. This instruction sets the timer mode to 8-bit auto reload for timer 1. This instruction initializes the high byte of timer 1 for the correct baud rate. This instruction sets the serial control register to mode 1 for 8-bit variable baud rate. This instruction starts the timer 1, enabling the serial communication. Now from here on our LCD initialization will take place. That means these are the instructions that are required for our LCD to start working. Now this instruction sets the cursor to the first position on the first line. Now after this is executed, now when this instruction will execute, it will jump to the label that is text 1. Now let us see what text 1 represents. As we can see over here, text 1 represents RFID based. Now this will be printed in the LCD. That means this will be shown in the LCD. Now after this instruction is executed, it will jump to this instruction. This instruction sets the cursor to the second position on the first line, on the second line. Now after this, now this instruction will be executed, and then it will jump to the label of text 2. Let us see what text 2 has. Text 2 now has attendance system. So by now our LCD should have displayed RFID based attendance system. Next, here comes the RFID initialization. So now this is the main loop. This instruction initializes a countdown timer R3 for reading the RFID input. So whenever the input will come, then it will compare to this 12 bits of data, and then if it is correct, then it will display on the LCD, else it will go to the next instruction. Now this instruction sets the register R0 to point to the memory address for incoming RFID data. Now over here, uh, this will call it delay. This instruction will call a delay, and then this creates a delay loop for serial communication. Now again the LCD initialization will take place, and then over here, when this instruction is processed, it will set the cursor to the first position of the first line of the LCD, and then it will display D1 hash D1. Let us see what D1 contains right now. D1 contains scan ID card. So this one, and then afterwards the next code, as we can see, we can see that it will jump to D2 instruction. D2 instruction will have MPMC class. So now the LCD will display scan ID card of MPMC class. Next, after this, this is our RFID loop. Now, this instruction waits for a serial interrupt indicating data is ready. Now, after this, if there's after the data is read, it will increment the register R0. That is R0. We can see over here. That means it will increment to the address 21H. That means whatever data is coming, it will store to 21H, and then it will decrement R3. That means this 12-bit data will be if the data which is obtained is correct, then the 12-bit will reduce to 11-bit, like that. And then this will compare if 3 R3 and then is 00H. Next, this command clears the display, and then again the same code is running over here. That is the LCD code. Now over here, this is the code for checking. Now these instructions are for person 1. So first it will move to this 20H address will be moved to the register R0. Now it will compare if R0, the address which is present in R0 is like equal to 3. If it is not 3, it will jump to the person 2, or if it is 3, it will increment R0 and then it will jump to the next instruction. Like that, it will keep comparing for all these digits, that is 3 7 0 0 A 2 3 C B 4. Now if all the instructions are correct, then it will print person 1. Next, and then it will increment the count of R0 and then count of R4. Now these registers are for counting purpose. Now next, it will jump to the again it will display, this is for LCD display, and then if all the instructions are correct, the LCD will display student 1. Let us look what is there in student 1 right now. Student 1 has Sujal 2 to BEC 1 to 0. So it will basically print that Sujal is present. And then we'll have student 1, and then over here again the command will be PR1. Let us see what is there in PR1. PR1 will have present, like that. And then it will after this the command will be present, and then next if and then next it will jump to person 2. Again it will check for person 2, and if the data is not the data which is obtained from here does not match, then it will jump to person 3, else it will print that person 2 is present. Now again it will jump to person 3, and then if person 3 is also like this data doesn't match person 3, then it will jump to error. Now let us look what is there in error. Now now these subroutines are for connecting the LCD to the microcontroller in order to display, in order for the LCD to display. These are the command and data. Now delay, this subroutine will provide a small delay where whenever it is called in the program, then it will create a small delay. Now this instruction is for counting purpose. This subroutine Now this subroutine this displays a string of characters on the LCD. It reads characters from the data pointer until it reaches 0. That means the end of the string. This subroutine will basically control an output signal based on the value of R4, indicating which relay to activate. That means if suppose if this is active, then it will go to this instruction, that is 1, and then let us see what is there in 1. 1 indicates that 1 out of 3 are present, and then again if this is not true, then it will go to this instruction, and then it will print this tag, that is 2. Let us see what is there in 2, that is 2 out of 3, and then if this is not there, then we'll go to 3. Then let us see what is there in 3. This will have 3 out of 3. like that. So this is our code. Thank you.
Okay, so now coming to the simulation part, we have simulated our project, which is RFID based attendance system in the Proteus software. So this is the circuit diagram which I have simulated in the Proteus software. This is the microcontroller 8051. This is LCD, and the data pins of this LCD are connected to port 1 of a microcontroller. This is a virtual terminal which I have used here as RFID reader. This will read the value of RFID which have 12 digits in it. It will read the value and it will transfer it. It will transfer it serially to the RX pin of this microcontroller. And let's start the simulation. Okay, you can see this simulation. Now I am going to write the 12 serial digits. So this was an unauthorized person, so it has declared it as unauthorized. Now I am going to type the second person. Yeah, this person was authorized, so it has shown as authorized, and it has increased the attendance to 1 out of 3. Now I am going to type the third person. This person was also registered in the controller, so it has shown it as registered, and it has increased the count, which is now 2 out of 3. So this was
Now we are going to see the demo of the project. So now we are on the switch. So this is unauthorized card, and remaining all 3 are authorized card. So we are going to scan one by one. So scan. So I am scanning first, and it shows 1 out of 3 student present. Now this is second one. It is showing 2nd out of 3. This is third one, and it shows 3 out of 3 student present. And now we are going to scan unauthorized students. And this is showing unauthorized.